This is the second lesson from chapter 17 on volumes of revolution. This would have been the warm-up if we'd not had to do the third quarter test today, so I thought I'd still show you this question here. Now, the key thing about this question is, unlike the questions you did last lesson, they haven't given you any limits for this question, so we've got to figure out the limits by actually sketching this graph, which I've already gone ahead and done. So the x limits here we can see are 0 and 3. So pi y squared dx, and we know that y is this equation here because they gave us that, so negative 2x plus 6 squared dx. Now we could go ahead and do FOIL on this, but since we know the inverse chain rule, we might as well go ahead and use that as well, just to remind ourselves. So increase the power by 1, divide by the new exponent, but also don't forget to divide by the differential of what's inside the parentheses, which is negative 2. And I've still got to times all of that by pi as well. So we'll just leave that to the side for right now. Now if we go ahead and plug 3 into here, we get negative 6 plus 6, which is 0. 0 cubed is 0, and 0 divided by negative 6 is 0. Sometimes by doing the inverse chain rule, it actually simplifies what you're actually trying to work out, as you saw just there. So plug in 0, we get 0 plus 6 cubed, which is 216. Divide by negative 6, so we're going to end up with negative 36. And when we simplify this, we get 36 times by the pi at the start of the question. So 36 pi would be our answer for that question. Now, much like when we did areas with integration, we looked first of all at the area between just a single equation in the graph, and then we looked at the area between curves. And we can do the same thing with volumes as well. So we looked at the volumes first of all just for straightforward equations, and then there's also equations for if we rotate with two curves. Now when we did it for area, we just said it was the integral of f of x minus g of x, and then we brought that together into one integral, and we can do the same for this one as well. So what we're going to do is we're going to do pi f of x squared minus pi g of x squared. As both of these have a pi, I just brought that to the front of the integral between our two limits. Now it doesn't sound too complicated, but you've got to be very careful in the order of operations on this. Some people put this one by mistake. They do f of x minus g of x, like they did for area, and then square it, which actually gives you something totally different. So make sure that you square before you subtract. So square each one, then do the subtraction, and then work out what that gives you. Now if we apply that to a question, find the area between y equals 4x and y equals x plus 9. Now I've drawn in a little graph so you can see what this actually looks like. We can see that it's between here and here. And if I was actually to slide this graph up, you can see that the limits are 0 and 3. Now you're not going to quite be as lucky as that, so you might have to do this algebraically. So we just set the two equations equal to each other and then go ahead and solve. And also from the picture, as it says the y-axis as well, we know that x equals 0 is the equation of the y-axis. So write out your formula to show the examiner you know what you're doing, and then substitute in the two equations. Now once again, just to make sure we got this the right way around, this one is furthest away, or this is the highest one up, so we should be using this one as f of x, and you can clearly see this goes through 9, so this must be x plus 9 here. Minus g of x all squared, and then we can start to work out the answer. Now x plus 9 squared, I could do FOIL on this, and I chose to do that this time, and I can distribute the 2 inside, so 4 squared and then x squared. I can collect terms together, and then I can go ahead and integrate, and then I can go ahead and plug in my numbers. All stuff that you should be familiar with doing now, having completed chapter 16. And if you manage to do that accurately, you should end up with an answer of 189 pi. Now I said we could do FOIL there, we could also do inverse chain rule as well. So same idea. You could do chain rule on this, but I would recommend that you just distribute and then integrate. So if you were going to do that, you could increase the power by 1, divide by the new exponent, but then also divide by the differential of what's inside the parentheses. 4 cubed here is 64. And I can see some common factors in here. Certainly these are both going to divide by 4. So I could say that this is 16x cubed over 3, which is what I got down here. I think that's overcomplicated, and I think it's easier just to distribute the 2 inside here, with this just being a monomial, and then increase the power by 1 and divide by the new exponent. So x plus 9 squared, increase the power by 1, divide by the new exponent, divide by the differential of what's inside the parentheses, which is easy for this question because it's just 1. Go ahead, do the same thing as before. Once you've got your limits, plug those limits in, and you do end up with exactly the same value, 189 pi. I think one of the key steps for this question is, going back to the graph, this very first step, trying to figure out what the limits are if they don't give them to you. So realizing if we use the y-axis, that would be 0 as one of the limits, but also to find where graphs intersect, you're going to set the 2 equations equal to each other. Sometimes you just have to set the 2 equations equal to each other to find the 2 values, but this time we're using the y-axis as one of our boundaries. That should enable you to work a little bit further into exercise 17. So try questions 4, 5, 6 and 7. We're just going to do parts A right now because that's revolving around the x-axis. And then when we get to lesson 3, we're going to look about what happens if you revolve around the y-axis.